How to factor difference of squares in algebra. Have you ever stumbled upon an expression that looks tricky, but you just know there is a simpler way to handle it? Today, we are going to talk about a specific method called factoring the difference of squares. This technique is a handy tool in algebra that can make your life easier when working with polynomials. So, what exactly is the difference of squares? It refers to a binomial, which is an algebraic expression with two terms, that is the subtraction of two perfect squares. A perfect square is simply a number or expression that can be expressed as another number or expression multiplied by itself. For example, if you have a 2b2, both a 2 and b2 are perfect squares. The key formula to remember is a 2b2 is equal to a plus b, ab. This means that you can factor the difference of squares by writing it as the product of the sum and the difference of the square roots of the two terms. Let's break this down into a step-by-step process. First, you need to identify the difference of squares. Make sure your expression has exactly two terms, both of which are perfect squares, and that they are separated by subtraction. For instance, take 9x2 16. Here, 9x2 is 3x2 and 16 is 4x2. Next, find the square roots of each term. For 9x2, the square root is 3x, and for 16, it is 4. Now you can write the expression as a product of binomials using the formula we discussed. In this case, it becomes 3x plus 4, 3x4. Before you finish, check for a greatest common factor. If your expression has a greatest common factor, factor it out first before applying the difference of squares method. Let's look at a couple of examples to solidify this concept. First, consider x2 25. Both terms are perfect squares. x2 is x2 and 25 is 5/2. The factored form is x plus 5, x5. Now how about 81x2 16y2? Here, the square roots are plus sqrt 81x2 is equal to 9x, and plus sqrt 16y2 is equal to 4y. The factored form is 9x plus 4y, 9x for y. Lastly, let's factor x4 plus 9. Rewrite it as 9x4 to see the difference of squares clearly. The square roots are 3 and x2, leading to the factored form 3 plus x2, 3x2. Factoring the difference of squares is not just a neat trick. It has practical applications, like simplifying algebraic expressions, solving quadratic equations, and working with polynomial functions. Understanding this method helps break down complex expressions into simpler factors, making your algebra journey smoother. Remember, the difference of squares only applies when you have subtraction between two perfect squares. If your expression involves addition or terms that are not perfect squares, this method does not apply. So, keep practicing, and soon you will master factoring the difference of squares.